friends, so today we are going to discuss another question on the Rn method, and this question says, now we have different limits in the question, so we are surely going to have some different limits in the integration sign as well. The upper limit and the lower limit are going to be different, what we put at as 0 and 1. So we are not going to have 0 and 1 in this case, we are going to have some different, so we need to calculate it. So we have under root n upon under root r. Our basic purpose is, since we are given this and we are given the summation sign as well, so our basic purpose is to convert it into the form of r by n, function of r by n. And since this is our motive, so I'm just gonna simplify this expression. Just see how I do this. So I'm just gonna write the terms that are pretty useless right now. So we can actually write this n in the denominator of r and get a 1 by under root r upon under root n. Since this isn't multiplied with the whole of the terms, we can actually take this to the top and get the same term. So it's just to make the r by n form, and to make this the r by n form, I'm just gonna write this as it is. Let's figure out how to write this in the r by n form. If you notice carefully, if I divide this expression by under root n, we get a root n, and this gets 1. So both the terms are beneficial for us, so I'm just gonna write that also. Let me just show you how I'm gonna do that. So 1 upon under root r by n, our r by n form 1 is made, and now our purpose is to make this an r by n form. So if I'm gonna divide this by n, I'm also needed to multiply this by an n. Now dividing this n, why I divided by n is because to get when I send it inside the square bracket, it would get a root over it. What I'm saying is, it would be like this: plus 4 under root n upon under root n multiplied by n. Now this is a n in the denominator, which is very beneficial for us to make it into the form that we require. That is, we can actually take this 1 by n, since it is in multiplication with all of the terms, so we can actually just separate it out, and we have this expression in the denominator multiplied by, there was a square over here, and we have 3 under root r by n plus 4 whole square. So this is our form. I've just missed out the limit, and now we are here. So we have pretty much made the form of r by n, and now we are gonna just convert this form into the definite integration form. So r is equals to 1. When we put it into the r by n, when we put r is equals to 1, and since n is tending to infinity, we get a 1 by n, which is equal to 0. And when we put, which is the lower limit, so we have a lower limit as 0 only. And now r by n, when we put r is equals to 4n, we get something like this, and the upper limits is 4. So we are gonna apply 4 over here, and let me just clear this calculation. So our purpose was to find the upper limit and the lower limit of the integration sign, which we have already done by the calculation which we just did. If you want to review the calculation, you can just go back into the video and see it. So our upper limits and lower limits are decided, and 1 by n gets converted into the dx. So 1 upon under root x plus under root x multiplied by 3 root x plus 4 whole square dx. Now to solve this, we are actually gonna require some skills for the solving of the integration. So now to solve this, we can actually take 3 under root x plus 4 as t. Now differentiating both sides, we have 3 by 2 root x dx is equals to dt. So we are missing 3 by 2 in this form, so we are just gonna, since these are constant, so we can actually multiply them and their reciprocal out of the integration sign, so that these term gets cancelled, and we are not making any changes in the question. And now we can actually just take this as dt. So we have a 2 by 3 dt upon t square. Now solving this, we have t to the power minus 2 So t to the power minus 2 plus 1 upon minus 2 plus 1, and the limits were from 0 to 4. So we have the limits as 0 to 4. Now 2 by 3 t to the power minus 1 upon minus 1, 0 to 4. So we have 2 by 3, 1 upon minus, this minus gets over here, 1 upon 3 root x plus 4 from 0 to 4. Solving this, minus 2 by 3, 1 by under root 4 is actually 2, so 6 plus 4 minus 1 upon 4. By putting the 0 we get 1 by 4. Now minus 2 by 3 into 1 by 10 minus 1 by 4. Solving this further, we have minus 2 by 3 into 2 minus 5 upon 20. So we get, solving this, we have minus 2 by 3 into minus 3 by 20. These terms get cancelled and we are left with a 1 by 10. So this is our final answer. Thanks for watching.